Scatter plots and correlation. In the first two modules, we looked at how to analyze a set of data by describing the central tendencies, the spread, and the position of data in the set. In this module, we focus on the relationship between variables. How do we know if what happens with one variable is related to changes in another variable? For example, is there a relationship between the amount of time studied and test grades? Intuitively, we think the answer should be yes, but how can we use statistics to support our assumption? We have learned that graphs can be very powerful in conveying the message the data tells. Not surprisingly, we again turn to a visual representation of the data to help search for relationships among variables. These graphs are called scatter plots, scatter diagrams, or sometimes scatter charts. Data will be in pairs, and we will graph just like you graphed ordered pairs in algebra class. The objectives we will look at in this module are to draw and interpret scatter plots, describe the properties of the linear correlation coefficient, calculate and interpret the linear correlation coefficient, determine whether a linear relation exists between two variables, and explain the difference between correlation and causation. So first, let's look at how to draw and interpret scatter plots. Scatter plots require at least two variables. The explanatory variable goes on the horizontal axis. You may have also heard this referred to as the independent variable in algebra. The response variable goes on the vertical axis. You may have also heard this referred to as the dependent variable. The response variable is the variable whose value can be explained by the value of the explanatory or predictor variable. If I were trying to determine if there is a relationship between the amount of time students spend studying and their grades, the study time would be the explanatory or predictor variable, and grades would be the response variable. Think of it as trying to determine how grades respond to study time, or that study time can be used to predict or explain grades. Suppose an engineer wanted to determine how the weight of a car affected its gas mileage. Which variable is the predictor variable and which is the response variable? The engineer thinks changing the weight will affect gas mileage, so gas mileage is going to respond to changes in weight. You might also reason that weight can be used to predict or change gas mileage. Either way, the predictor variable is weight and the response variable is miles per gallon. A study finds that short women are more likely to have heart attacks than women of average height, while tall women have the fewest heart attacks. Identify the response and predictor variables. Height is a predictor of heart attack risk, so height is the predictor variable and heart attack risk is the response variable. A scatter plot is a graph that shows the relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis and the values of the other variable appear on the vertical axis. Each individual in the data appears as the point in the plot determined by the values of both variables for that individual. This is exactly like graphing ordered pairs on the x and y axis in algebra, except most statistical graphs are only in the first quadrant because we are usually dealing with positive quantities in statistics. The data shown to the right are based on a study for drilling rock. The researchers wanted to determine whether the time it takes to dry drill a distance of 5 feet in rock increases with the depth at which the drilling begins. So depth at which drilling begins is the explanatory variable x, and time in minutes to drill 5 feet is the response variable y. Draw a scatter diagram of the data. This graph was drawn by hand on a computer, which means I did it in Paint and did with the computer what I would do with paper and pencil. The next slides show how to do this on a TI-84 calculator and Excel. You can also create scatter plots at this website, and you can set the scales on the x and y axis at this site, and then you would use your mouse to plot points just like you would do with pencil and paper. I'm not going to dwell on these TI-84 slides. If you're going to use a TI-84, you need to print the slides and then go step by step through the directions as you enter the data. And this is what the TI-84 scatter plot looks like. And then if you use Excel, you would select the data, then click the Insert tab, and choose Scatter from the array of plots. Choose the one that doesn't have the lines connecting it. And then this is the graph you get. You can add a title and label the axes, and the directions may vary somewhat depending on your version of Excel, so you can just search the web for directions if you can't figure out how to do the graph if you're using Excel. Notice this plot looks different than the Excel plot because the vertical axis scale has been shortened. Let me go back. Here's the Excel. See, it starts at 0. And this one does not. And you'll recall we talked about how changing the scales can affect the way a graph looks and could be misleading. In this case, all it does is let you zoom in on the points in your scatter diagram. Two variables are positively associated if whenever the value of one variable increases, the value of the other variable also increases. So to the right, as we go up the x-axis, the points also have larger y values. So that gives us going up as we go across the page. That's a positive correlation. Two variables are negatively associated if whenever the value of one variable increases, so our x's are going up, the other value decreases. So in this graph, as the x's increase in value, the y's are decreasing, so that gives us a line that slants across the graph going down as we go across the page. And if you remember from algebra, lines that go down have a negative slope, and lines that increase, like the one at the top, have a positive slope. This is more examples of relations in a scatter diagram. The top left plot would be a linear relationship with a positive relationship. The one on the right is a negative linear relationship. And these on the bottom are various ones that are not linear. And you can tell that saying something is nonlinear doesn't mean there's no relation. It's just not a line. Clearly there's some kind of curve here and here, and there's not a whole lot going on in the one on the right. Create a scatter plot using the data on the following slide, and you can do this by hand. You can use Excel, a graphing calculator, or use that website, just as long as you understand the concept. And remember, on the website you can type in whatever numbers you want for the scale to fit your data and then plot the points. And again, you'll likely have to add a Java exception to allow the above site to run on your computer. So draw a scatter plot of the following data, which examines the relationship between the amount of sleep history students got and their grade on a test. Stop the video here and complete your scatter plot before you look at the solution on the next slide. Since we want to know if test grade responds to amount of sleep, test grade is the response variable and goes on the vertical axis. And this is what your scatter plot would look like. It does look like the relationship is linear because we could put a line right through here. Here's a PGA problem for you to work on. A popular saying in golf is you drive for show but you putt for dough. Use statistics from this lesson to support or refute this claim. We will revisit this problem in a later lecture. Now take Module 3, Part 1, Assessment of Learning. The password is scatter, all lowercase.